morning, and welcome to the CGI version of the Lightning Talks this morning. My name is Dave Reed. I lead CGI's biometrics, identity, credential, and access management practice, which has been around for about 15 years in one form or another. We've been working with the Army and doing biometrics that whole time. Go ahead and move me. Oh, I guess I have a clicker here. Excellent. Okay, so why do we care? Why are we interested in biometrics as it relates to the network? Well, what we see out in the marketplace, both in the civilian commercial market and with the Army, is that people are moving their data more and more into the cloud. Not just data, but analytics and analytical services and some of the products that come out of those live in a cloud. But the end users are all around the edges. So you have people with smartphones and with tablets, and especially in the modern Army, you see I think you're going to see a trend more and more towards soldiers out in the field with smartphones and tablets as their primary access device, because the commercial world is moving faster than the Army. These devices are cheap, they're light, they're durable, they're very high-functioning devices. But the problem is you need to be able to protect the data, to grant access to the people who need access and deny access to the people who shouldn't have access. To do that, you have to use some sort of multi-factor authentication. There are some user requirements for mobile authentication in general. CGI has been doing biometrics, as I mentioned, for about 15 years with the Army. The effect of this is that we've seen how biometrics and multi-factor authentication gets used in the real world and the implications for how users react to it. So users have a bunch of requirements, actually many more than just what's on this list. This is really just for mobile authentication. So the first thing is the device has to be fast and easy to use. When you go to authenticate, it can't take 30 seconds or a minute or involve a lot of interaction with the device. It has to be quick. You have to be able to do it with no additional hardware. I see people all the time say, oh, well, DoD has CAC. We'll just authenticate with a CAC card over my mobile device. But that means you have to have some sort of dongle on the device that can read the CAC card. That's additional hardware. Users don't like to carry it. It gets lost. It gets broken. They just won't do it. So it has to be able to work with just the device with no additional hardware. Finally, it has to have low failure rates, which means from the user perspective, not necessarily false accepts, because the user doesn't really care about false accepts, but users do care about false rejects. They care about the system telling them, no, I think that's not you, and I'm not going to let you in. So you have to minimize the false reject rate for users to really want to use it. For security purposes, of course, you have to minimize the false accept rate, but that's another discussion for another day. There are also a number of best practices that we've discovered over the years just from doing this kind of work day in, day out. The first one is that you should always do multi-factor authentication. Just username and password, that single factor, as you've probably been told a million times, it's dead. It's never coming back. You really can't protect things effectively with passwords. So you've seen two-factor with like RSA tokens, but even RSA tokens have been broken. And so when you add a third factor, the biometrics, to the something you knew, the something you have, and the something you are, the biometrics is the last piece that you need for that strong authentication. But it goes a little farther than that. You have to use strong biometrics. So everybody who's seen their iPhones and the latest Samsung Galaxies that have the fingerprint sensor in them, those fingerprint sensors are not what I would call strong biometrics. And it's not that there's anything wrong with fingerprint, there's something wrong with the sensors in those devices. They just don't collect enough data, and they have a way too high false accept ratio. They're too easy to spoof for an attacker to be able to get into your phone without having your finger there. So you have to use a strong biometric, something that has a really good false accept rate in addition to the false reject that we mentioned earlier, in order to make this system worth using. It's also important to understand that these devices, these phones and tablets, they're computers like any other. And if you think that an attacker hasn't compromised the machine, you're probably wrong. So whatever you do, you have to not trust the device too much. And what I mean by that is it's very easy to do authentication on the device and have the device call your server and say, hey, I authenticated the guy, here's his token. Well, how do you know he really authenticated the guy? How do you know that an attacker didn't penetrate it and just steal the token right off the machine and hand it back to your server? So you have to be careful about how much you trust the device. And there are ways around that, and I'll show you one later in a few minutes here. One of the key pieces to good mobile authentication is proving the user's identity before enrollment. So enrollment's that part where you collect the fingerprint or the iris or whatever it is you're going to match on. You have to make sure that you have the right user when you do that, because if an attacker stole your soldier's phone and goes and enrolls in the system using his own fingerprint or his own iris or voice or face or whatever, then you've just granted elevated privilege to the attacker, and you'll never know that it wasn't the attacker after that, right? Because it's going to be the same person who enrolled. So you have to prove the person's identity before you accept that biometric data for enrollment. And this is a step that many, many systems overlook, and it's a critical weakness when they do. So you have to be really careful about that. Encryption everywhere, so that means encrypting all your biometrics and tokens and certificates, both in transit and at rest on the device, and using PKI wherever you can, at least wherever it's appropriate, because there are identification mechanisms built into PKI depending on how you do it. So if you do all of these right, you end up with a reasonably secure system. So we set out to design a system that met the user requirements and followed all the best practices. What we came up with is a piece of software we call Eligo Mobile. Now, Eligo is a larger biometric framework that we've developed. Eligo Mobile is just a component that deals with phones and tablets and that sort of thing. It's a flexible framework for mobile authentication. And what I mean by flexible is that it can connect into anything. We have done trial integrations with MDMs such as Good or AirWatch or Mobile Iron, any of those. We've rolled it into securing SharePoint sites and Outlook web access, you name it. I mean, we have it in progress right now at a couple of large European banks. It's a system that's really meant to plug into lots of other different systems. It's agnostic to biometric modalities and algorithms, and if you're not from the biometric space, modality is fingerprint or iris or face or voice. It's the specific biometric that you're looking at. The algorithm is whose implementation that you're using to say that these two really are the same fingerprint or the same iris or the same face. So within one modality, you can have lots of different people implementing algorithms. We have a plug-in architecture that lets us plug in modalities and plug in algorithms, which means that if something new and sweet comes down the pipe next year, we can plug it in and replace what you're using now. It's a really neat system. It's very easy to plug in new things, makes it very usable. And then, as I mentioned, the identity proofing is really critical, and we have a built-in mechanism for identity proofing that uses out-of-band encrypted tokens sent via QR code. It's really slick, very easy to use. Banks like it because they can present these tokens over ATM channels, so they already have a two-factor authentication for the user who goes to get the code. There are lots of other ways of doing it. This is just the one we have built in today. There's a whole framework for building in identity proofing. Okay, so that's the description of the solution. I'm going to show you the thing in action. Can you flip me over so we're live? Now, I'm doing a live demo in an unconstrained environment, so I'm really just hoping my phone doesn't catch on fire. No, we're still there. Okay, and excuse me, we have some resolution problems we were unable to work out, so you don't see the whole iPhone screen, but trust me, it's just a plain old iPhone. I'm going to launch this application that we call XBank. This was a demo application we built for taking this technology to banks. So it's skinned to look like a banking application, but there's nothing special about it. And in fact, it has no banking stuff behind it. Really, it's just there to show off the authentication process. So I'm going to tap this button that says Login. It's going to say, give me your username and password. Now, this is configurable. We just keep it in the demo just to show that we really can collect username and passwords. And now you're going to see this little roving green line. It's looking for my eyes. And in just a second, you'll see that fast. It's captured my eye and logged me in. So what happened there is this is software from a company we really like called iVerify. The product is called iPrint ID. And it's not iris. And that's a really important thing to understand because iris cameras have some very special requirements in order to make them work. They're expensive, they're hard to deliver. And I think Microsoft just announced the first phone-based iris camera last week in their Lumia line of phones that they bought from Nokia. Remains to be seen how well that works because there are some optical challenges and there's some illumination challenges that they have to solve. What this thing does is actually uses the veins in the corner of your eyes, here and here. That actually is capturable with the front-facing camera on something like an iPhone. They also have some really clever encryption technology so that it does the matching on the phone, but what it does as part of the matching process is essentially extract a PKI key out of the pattern of veins in your eyes, and it uses that for the verification transaction with the server. So it's really clever. It does all the things we want. It has the part where I don't have to trust the phone. It's fast, it's easy, it's secure, it's very reliable. It has probably, of anything I've seen in the mobile space, it has the lowest false accept and the lowest false reject ratio of any mobile biometric I've seen. We really like this thing. We also have plugins for face and voice if you want to talk about those. I invite you to come over to our booth. We're in booth 2453. I can actually see the CGI banner from here back there in the hall. I'll be there all day today, so by all means come by and say hi. And if you've got questions, bring them on.
Okay, I'm going to ask the first question. Could I spoof that particular modality with software with the photo?
No, you can't, and the reason is that it's actually what you can't see. The reason it took as long as it did to capture the eye is it's looking for little micro twitches in your eye that you can't control, and it not only detects the fact that the image shifted, but it's able to do a 3D mapping to verify that it's actually a spherical surface that those veins are moving around on. Excellent. So it's really clever. I've yet to see this thing spoofed successfully.
Okay, I gave him the easy question. Someone give him a hard one.
Yeah, I'll take the softballs all day.
How about our friends from the UK? Any hard questions?
I even understand the Queen's English, so you can just bring it.
Sir, where are you on getting the Army interested in your technology? Or are you still, because right now we do have smart tablets, you know, they're through their, there are multiple tablets out there.
Right, so we've had discussions with various Army components over the years, and we're still looking for that first customer. I think the Army's problem is everybody thinks that CAC is the be-all, end-all of authentication. Right. And then for the mobile environment, you hear a lot of talk about derived credentials, but derived credentials are the technology that's always arriving next year, so it's free beer tomorrow for authentication. So I think we'll get there with derived credentials, but there's still, then comes the problem of how do you protect the credential itself, and that's where you could still use something like this. I would say probably our biggest nibble in terms of trying to